video lesson to show operations with radicals. Radicals have a square root sign in them, so that's how you're going to recognize them. Let's turn to our lesson page. There we are. So let's talk about what radicals are. So square root of 12 is an example of an entire radical. The square root of 12 has one number underneath a square root sign, and this is actually going to be, we're going to be able to simplify it, and I'll show you how. 2 root 3 is an example of a mixed radical. So a mixed radical has a number under the square root sign, but also has a number in front, and this is multiplication. So let's read this. In general, radical expressions should always be simplified as reduced mixed radicals, I will show you, with natural denominators. The natural denominator refers to if your answer is a fraction, the denominator cannot have a radical in it. It must have a whole number. So in our mixed radical, we have a whole number and we have a radical. And if our answer is a fraction, we will not have a radical in the denominator. So some of the properties are that the square root of a product is equal to the product of the square roots. And it says a greater than or equal to 0 and b greater than or equal to 0 because if a and b were negative, we can't do this because we can't take the square root of a negative number. Similarly, the radical of a quotient, so division, is equal to the quotient of the radicals. Okay, so we're going to use these to simplify some of these radical expressions. So let's look at the first one, the square root of 75. That's an entire radical. That can be simplified. The way we simplify is we look at the number 75 and we try to break it up into a product where one of the numbers is a perfect square. So what are the possible perfect squares? So I'm just going to write a bunch of perfect squares up here. 1, 4, so 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. Is one of these a factor of 75? And it is. So what we do is we split out the 75, so into 25 times 3, always putting the perfect square first. Alright, now we use this property up here that says the square root of the product is equal to the product of the square roots. That means we can split this into a product of root 25 times root 3. But root 25 is a whole number. That's just 5. So that's what we have. We have a mixed radical, and that's reduced. Okay, let's do the other one. This b is a fraction, but the second property says that we can split this into root 2 over root 9. Okay? This is helpful because root 9 is just a whole number 3. So this is root 2 over 3. Okay, next one. So when we're doing operations with these things, we multiply, so this is a multiplication. We're going to multiply the whole numbers with each other. So the 9 and the 4, we're going to multiply with each other and get 36. And then we're going to multiply the radicals. So root 2 times root 7 is root 14. And since 14 does not have a factor that is a perfect square, so none of these numbers divide into 14, we can't simplify this anymore. So let's do d. So once again, it's going to be the whole numbers multiplied together, and then the radicals multiplied together. So I'll get 10 root 18. Now this can be simplified further because 18 can be written as a product of numbers where one of them is a perfect square. So 9. So what I'm going to do, I'm going to write root 18 as root 9 times root 2. But root 9 is a whole number. It's 3. So this equals to 10 times 3 times root 2, which is 30 root 2. Okay, the last question. It seems like we want to reduce this 6 and the 3, but we can't do that because in a fraction you cannot divide just one number and the denominator by something. You've got to divide everything by the same number. Right now, this root 45 is not divisible by 3. But what I can do is I can simplify root 45. So I can write it as 6 minus root 9 root 5 over 3. Okay. Now I can write the root 9 as a whole number and then divide each of these terms by 3. Now, dividing means I'm only dividing the whole numbers, not touching the radicals. So dividing everything by 3 is reducing the fraction. So the 6 becomes 2, 3 root 5 becomes just root 5, and the 3 in the denominators becomes 1, so I'm not going to write it. Okay, so that's how to simplify those. So we saw properties for multiplying and for dividing radicals, but there are no properties for adding and subtracting radicals. We have to treat adding and subtracting radicals like collecting like terms. Okay, so right now root 12 and root 18 are not like terms. I cannot add them together, and root 27 and root 8. They cannot be added together. But if we simplify all of them, we might be able to get like terms. So I'm going to go through it fairly quickly. You can pause the video, try to do it yourself. You're simplifying each of these by themselves, and then we're going to see if we can find like terms. So please pause the video, do it yourself, and come back, check with me. Okay, now that they are simplified, we can add the root 3's with the root 3's and the root 2's with the root 2's, just like collecting x's and y's in an algebraic expression. So 2 root 3 minus 3 root 3 is negative 1 root 3, and 3 root 2 plus 2 root 2 is 5 root 2. And that's the end. That's simplified because these two are not like terms. They cannot be added together. So let's do it again for the next question. I'm just going to start you off. Okay, 3 root 20 is going to be 3 times root 4 times root 5. Okay, and then the root 4 will become a 2. Since this is multiplication, you'll have 3 times 2 times root 5. So pause the video, go ahead and try it on your own, and then we'll check. Okay, and so what I've done is I've simplified each of these things. You've got to be careful. Sometimes you have to do these multiplications. Then at the end, you're adding like terms with like terms. And that's my final answer. Okay, let's flip to the next page. So more complicated expressions, but they're really no different than just algebra. So take a look at this one over here. This is a radical, it's a mixed radical times a binomial. So all we're going to do is we're going to expand with distribution. This one over here is a binomial times another binomial, so we're going to use the expansion like we do like with FOIL, with x plus y times x plus y. And we're going to do the same thing over here, only notice, haha, this is special. This is a plus b times a minus b, which you should recognize as something special. But you can go through with the expansion, pause the video, and come back and check with me. Okay, so looking at the first one, we're just distributing. Remember, whole number times the whole number, radical times the radical, simplify and add them up. The second one, you're going to have 4 terms in the expansion. Now, notice what we can do to make life a little easier. 3 root 2 times 4 root 2. We could say that's 12 root 4, but then we have another step to figure out what's root 4. Easier than that is to say root 2 times root 2 is 2, because root 2 times root 2 is root 2 squared, and square root and squared, they cancel each other out, so you're just left with 2. Similarly, root 5 times root 5 is just whole number 5. Okay, so we can do things like that. If you expand the second one, the middle terms cancel out. Why? Because it's a difference of squares. So the middle terms go away and you're left with negative 5. If you notice up front that it's a difference of squares, you could remember what difference of squares looks like. and that's just a squared minus b squared, and then you can just take the a, which is root 7, and square it, and the b, which is 2 root 3, and square it, and then you can go directly to the answer. Okay, so that's it for simplifying. The last thing is that note about how the denominator can never have a radical in it. So this, we're going to take expressions that have radicals in the denominator and change them so that they don't. And the process is called rationalize the denominator. And rationalize comes from rational number, which is just a fraction with whole numbers in it, not radicals. So the way we do it is a very cool trick that we will use many, many times in grade 11, which is to take this fraction and multiply it by a fake number 1. Okay, a fake 1. The one that I'm going to choose for this one is going to have root 2 at the bottom, so that when I multiply the fractions, I'll get rid of the radicals in the bottom. But I can't just multiply by root 2, that changes the question. So I'm going to have to multiply by 1. The way I get a 1 with root 2 at the bottom is root 2 over root 2. So this is a fake 1. And it's always okay to multiply by a fake 1 because you haven't changed the question. So now when I multiply across, I get 3 root 2, and in the denominator, just a 2. And now we're rationalized. Okay, this one, I have this root 2 in the denominator. The 3 is not a problem because the 3 is not a radical. It's just the root 2 that's a problem. So my fake 1 doesn't have to include the 3, it just needs to include the root 2. So I'm going to multiply, and that's going to give me 8 root 2 over, sorry, I'll show you why. It is 6, but I'll show you why. Because it's 3 times 2. And that is 8 root 2 over 6. And we're done, except that we need to reduce this fraction. 4 root 2 over 3. And the last thing we need to talk about is what if there's a binomial in the denominator. So the way to rationalize the denominator is back to difference of squares. Right now, I have a minus b, and they are both radicals. But if I do difference of squares and multiply by a plus b, I'm going to get a squared minus b squared. That's not going to be a radical, and that's not going to be a radical because they're squared. So we're going to do a technique called multiplying by the conjugate. This is the conjugate. Multiply by the conjugate. The conjugate is the same as this binomial, but has a different sign. So let me show you how that looks. 5 over 2 root 6 minus root 3 times, remember, we're doing just a fake 1. We could multiply by a fake 1. The bottom is going to be the conjugate of this. And to be 1, the top has to be exactly the same. Otherwise, we're changing the question. Right? So nothing illegal yet, because that's still a fake 1. Now, if we work on the numerator is going to be 10 root 6 plus 5 root 3. Just multiply straight across. The denominator is a difference of squares. So it's going to be the first term squared, 2 root 6 squared, minus the second term squared. And when you square radicals, you're going to get whole numbers. So let's do that. 10 root 6 plus 5 root 3. And I have to square the 2, and I have to square the 6, the root 6. And then I got to square the root 3. So I'm going to have minus 3. And that's going to give me 10 root 6 plus 5 root 3 over 21. Okay, so please do your homework and bring any questions to class. Thanks.